Let's do one more example of var of par, but this time with some trig. So let's find a particular solution xp to x prime equals ax plus f, where a is 2 minus 5, 1 minus 2, and f is minus cosine of t, 5 sine of t. And so remember, the first step is to find actually the homogeneous solution. So homogeneous solution, meaning solve x prime equals ax. And this is, again, the eigenvalue eigenvector method. Once again, you can see the details in the notes. So here, lambda would be complex, plus minus I. And for example, for lambda equals I, you would find the eigenvector 2 plus I, and then 1. And to build our solution, remember, it's e to the eigenvalue t, so e to the it times eigenvector 2 plus I1, which once again, you want to split into real and imaginary parts. So cosine of t plus I sine of t times 2, 1 plus I 1, 0. And again, you want to FOIL it out. And eventually what you get, so we can go directly here, x0 of t is c1 times the real part. So in this case, cosine of t times 2, 1. And then I times I, it's minus. So minus sine of t times 1, 0. And then plus the cross terms, c2 cosine of t times 1, 0 plus sine of t times 2. So once again, what I did, I folded out, I split it into real imaginary parts, and I just took linear combinations with those constants. And now, unfortunately, we do need to write this in terms of vectors. So in this case, we get 2 cosine of t minus sine of t, and then cosine of t, and then plus c2, I think cosine of t, plus 2 sine of t, and then sine of t. And yes, it is getting very tricky here, unfortunately. But trig is the spice of life. All right, and now let's do var of par. So once again, that was the homogeneous solution. And now the idea is xp of t is some function u of t times the first vector. So 2 cosine of t minus sine of t, cosine of t, plus the second vector. So v of t, again, c'est la v of t, cosine of t, plus 2 sine of t, and then sine of t. And then you do the var of par equations. So you get 2 cosine of t minus sine of t, and then cosine of t, and then cosine of t, plus 2 sine of t, and then sine of t, times u prime and v prime equals to the inhomogeneous term, which I think was minus cosine of t and 5 sine of t. All right, and then I know, good luck. We want to do Cramer's rule. So let's look at the denominator, which you'll see simplifies like a charm, because we have 2 cosine of t minus sine of t. What? cosine of t. Cosine of t and then cosine of t plus 2 sine of t and sine of t. So let's multiply this out. So this becomes, I believe, 2 cosine of t minus sine of t times sine of t minus cosine of t plus 2 sine of t times cosine of t. And this gives you 2 cosine sine minus sine squared, and then minus cosine squared minus 2 sine of t cosine of t. And now you're welcome to the trig party, because a lot of stuff gets simplified. Those cross terms get simplified. And then remember, cosine squared plus sine squared is 1. So this whole thing in the end becomes minus 1. So here's the thing. If you have a trig example with var of par, be careful if the denominator doesn't simplify. It usually means you made an algebra mistake. Okay, and now let's do u prime. So I only do u prime and then I tell you the result for v prime. So u prime, you replace the first column by the inhomogeneous term, so minus cosine t, 5 sine of t, and then cosine t, plus 2 sine t, and then sine t, over minus 1. Right? So this becomes minus that, minus the determinant, so minus cosine t sine t, minus cosine t plus 2 sine t times 5 sine t, and again expand this out, so this becomes, I think, minus cosine t sine t minus 5 cosine t sine t, and then minus 10 sine squared t. So minus 1 minus 5, that's minus 6. And with this minus 1, in the end, it becomes 6 cosine t sine t plus 10 sine squared t. And I'll just write down what happens for v prime. So for v prime, it's the same thing, but you replace the second column by the inhomogeneous term, 5 cosine t minus sine t, and then cosine t, and minus cosine t, and then 5 sine of t, again, divided by the denominator. And this you can see in the notes, and it becomes minus 10 cosine t sine t, and then plus 5 sine squared of t minus cosine squared of t. Okay, unfortunately, we need to integrate all this. So remember, u prime of t was 6 cosine t sine t sine t plus 10 sine squared t. And so you integrate, u of t is integral of 6 cosine t sine t plus 10 sine squared t dt. And here we need to use our trig laws. So cosine sine, that smells like sine of 2t. So it's 6 times 1/2 sine of 2t. And then the sine squared t, so there's a minus involved. So in this case, it's 1/2 minus 1/2 cosine 2. Remember from calculus how to integrate those functions. And then we simplify this a little bit. So this becomes integral of 3 sine of 2t plus 5 minus 5 cosine of 2t. Again, this is all fair game, all this trig. Cosine 2t. And then you integrate this. So antiderivative of sine is cosine. So in this case, I think we get, so antiderivative of sine is minus cosine. So you get minus 3/2 cosine of 2t plus 5t. And then in this case, minus 5/2 sine of 2t. Yeah, again, no constant. And if you're confused about this dividing by 2, I just use a u sub u equals 2t. So that was u of t. I will not torture you with v of t. So v of t, again, you integrate this monster, and then you can get 5/2 cosine of 2t plus 2t minus 3/2 sine of 2t. And then we have finally arrived at our solution. So xp of t. Forgot which step that was. I think that was all part of. Yeah, that was part of step 2. So step 3. So what is xp of t? Again, that is u of t, which we found minus 3/2. Maybe a new line. Need this. So minus 3/2 cosine of 2t plus 5t minus 5/2 sine of 2t times that vector 2 cosine of t minus sine of t, and then cosine of t. And so that is u, and then same spiel with v plus 5/2 cosine of 2t plus 2t minus 3/2 sine of 2t. And then times the second vector. So cosine of t plus 2 sine of t. And then sine of t. Whew! Well, that was a lot, but again, just to show you that the steps are the same and to put a little sprinkle of trig. I might do like inhomogeneous, or like a non-constant coefficient version for the final exam review. So you can also see how that works.